All right, so the next example on this practice final, let's see here. It says solve by the method of your choice this time. Solve by the method of your choice. And so you literally can do any choice you want. I'm going to actually use this graphing utility here again, and since it's very easy, very quick, and you can type in the equations just as you see them. 4x plus 12y equals 24. 4x plus 12y equals 24, and 3x plus 9y equals 18. Take a look at that. As I was typing that in, they ended up to be exactly the same line. Oof. What in the world does that mean? Well, let's take a closer look at that. This is why I want to start at the graph for this one. So we had 4x plus 12y equals 24. And we also had 3x plus 9y equals 18. Let's reduce both of those equations. And what I mean by reduce, this one here, 4, 12, and 24, they actually all have something very in common. They have a 4. So if I divide everything by 4, it won't change the equation, but it'll reduce it a little bit. So 4x divided by 4 is x. 12 divided by 4 is 3. 24 divided by 4 is 6. Now, those are exactly the same equations. They're just reduced. And so you can easily do that because whatever you do to one side, you must do to the other. And so we balanced it. I divided everything by 4, and so the equation was balanced. So that's the same equation as the one above. All right, next one here. 3, 9, 18. They all have 3 in common. So I'm going to divide everything by 3. So literally everything by 3. And I'm going to be left with x plus 9 divided by 3 is 3. 18 divided by 3 is 6. Same exact equation. Oh boy. Yeah, they're same exact equation. Since they're the same exact equation, there are going to be an infinite many solutions for this particular question. All right, will that happen every time? No. So, but if you have the equations like this, choose any method to solve, you can put them right here, and the intersection point is your answer. The thing is, with this one, the intersection point is every point, and that's why there's an infinite amount of answers. All right, let's check out the next question. So for this one here, let's see here. Solve the following exponential equation. Okay, but it says, let's see, each side has a power of the same base. Okay, well that's not too bad. Well, let's think about that. We have an 8, we have a 32. So those two, just by looking at the directions, they probably can be written with the same base. And so those with an exponent, let's think about that. 8, well, what goes into 8? Well, let's break down 8 real quick. 8, if broken down into 4 times 2, and that also breaks down to 2 times 2. Ooh, there we go. 2 times 2 times 2. 8 is the same as 2 to the 3rd power. 32, well, let's break that down. 2, let's think about 32. All right, so 8 is 2 over 3. Well, let's clear this out here. And let's try the 32. So let's break 32 down to see if we can get something similar. So 32, well, let's think about 32. Oh, that was a bad 2. All right, 32 breaks up into, let's see, we have 8 times 4. Ooh, well, I already know 8 is 2 to the 3rd power, so I'm going to just bring that down as 2 to the 3rd power. Okay. Oh, and 4, well, I know that that is 2 squared. So that means 32 is, well, I can break these all down, but basically have 3 2's here, 2 2's here. 2 times 2 times 2 times 2 times 2. Whew. So 32 is the same as 2 to the 5th. All right, so 32 is the same as 2 to the 5th. So this is where I see students make mistakes. This x plus 2 is on the 8, which means technically that is a parenthesis. Then you have the x plus 2 out here. Same thing on the other side. At 32, the whole thing is on the 2 to the 5th power. So the x minus 2 is on that whole x minus, or 2 to the 5th power, 2 to the 5th power. And what that means is we have a power to a power, which means we multiply. So as soon as we have the same bases, so we got the same bases, good to go, same bases. Now we just work with exponents. And since it's a power to a power, basically multiplying. Yeah, let's clean this up a little bit. Or multiplying. So that's going to be 3x plus 2. And then it's going to be 5x minus 2. All right, now we distribute and just solve like a regular equation. So first one, we have 3x plus 6. Other side, we have 5x minus 10. All right, and let's just keep chugging along here. Bring the x's to the same side, numbers to the other. So I'm going to subtract 3x on that side. All right, and then we're going to bring the 10 to the other side. So we're going to add 10. And what that'll do is that will cancel the 10s on that side. That'll cancel the 3x's on that side. And we're left with 16 equals 2x. All right, divide by 2. And we get x equals 8. Oh, that was a bad 8. X equals 8. So there you go. The solution set is 8. All right, let's keep going along here. So for this question here, we have, it says use the binomial theorem to expand the binomial and express the result in simplified form. Oh boy, this one here with the binomial theorem, that to me is a very complicated way to do this question. So I want to show you something called Pascal's triangle. And what this does is this will actually help us give placeholders for our expansion. And so let's take a look at what the Pascal's triangle means. And well, what it is first. Pascal's triangles, so you have 1, 1, 1. So we have this pattern here. So as you move down in Pascal's triangle, you simply add. Whoa, what do I mean by that? Well, let's look side by side here. All right, here we go. So Pascal's triangle started out with 1. That first row represents a degree of 0. So then the 1s come down. And then the 1 on the outside comes down. And now we combine the middle 2 to get 2. And now the 1s again come down. Now I combine the 1 and 2 to get 3. 2 and 1 to get 3. And the 1 comes down. Again, 1 comes down because you can't combine with anything on the outside. 1 and 3 gives you 4. 3 and 3 gives you 6. 3 and 1 gives you 4. And bring down the 1 again here. So this first row again was degree of 0. Here, let's make sure we have it lined up. Degree of 0. The second row is degree of 1, which is linear. Next row is degree of 2, which is quadratics. Next row is degree of 3, which are cubics. Next row is degree of 4. And the next row will be degree of 5. All right, so degree of 5. This next row is the one we need since we have a 5 for an exponent. So let's go for it. 1. All right, so 1 and 4 gives you 5. 4 and 6 gives you 10. 6 and 4 gives you 10 again. And then 4 and 1 give you 5. And then you bring down the 1. So that's the row that we need. That's the row that we need. So there it is. So this is going to be important because that's going to help us to determine our coefficients to this expansion. So I'm going to write that up here so we have it. So 1, 5, 10, 10, 5, and 1. So that's the row we need. All right, let's clean this up. So the question is, how are we going to use this? So these all here represent the number that's going to be multiplied by the coefficient. And so this is Pascal's triangle. Ready? This 5x here is going to be represented by A. That one's going to be the B. And the 5 will play a role. The 5 will play a role. So this is the order that it goes in. Because we're on the 5th row, it's going to be, so it's going to, you have the 1, then it's going to be A to the 5th power. Okay, and then next. All right, and now the next term, now here's the difference. If this here is a minus, we just alternate signs. If it was a plus, we just have plus straight through. So since that's a minus, first one was positive, next one's going to be minus. We have our 5, and this is where it starts to alternate. So the A is going to go down by 1, and then the B is going to be here. Now technically, the B is in the first one, and I will use a different color here. Technically the B is here, but it's a 0. And the thing is, anything to 0 power is 1. So I'll leave it there just so as a placeholder, but the B is technically there, but it's a 0 power. And so what's going to happen here is the A is going to count down 5, 4, 3, 2, 1, 0, and the B is going to count up 0, 1, 2, 3, 4, 5. And so we're going to keep going with that pattern. So now since it's minus again, this next one's going to be plus. We have the 10 here. And now the A is at 4. Now the A is going to be at 3. B is going to be at 2. And now again, we're just continuing to we're going to continue to use Pascal's triangle to expand this. So let's make some more room. All right, next, let's grab another color here. So we had minus, plus, and now next one's going to be minus. And it's going to be 10 in front here. And now A was at 3, so now it's at 2. And the B is going to now be at 3. All right, we'll grab another color to keep emphasizing, alternating here. And next, we're going to have a plus. Oh, that was a bad color. That one can probably barely be seen. There we go, that's better. We have a 5. The A is now down to 1. The B is now up to 4 for an exponent. And we have the very last one here. So very last one is going to be a minus. And the coefficient, extra coefficient is 1. And then it's going to be A to the 0. Technically I don't have to write it, but I'll leave it there just for emphasis. And then we have B to the 5th. So first thing we did was Pascal's triangle to figure out these very important extra coefficients. These extra coefficients here. And so we have our 1, we have our 5, 10, 10, 5, and 1. So those will basically help us to expand this binomial without using that crazy binomial theorem. Okay. And then next, what we did was, all right, well, our A is the 5x, our B is the y. Okay, and so the A just simply counts down from this exponent here. The exponent's 5, so A to the 5, A to the 4, 3, 2, 1, 0. And the B then counts up from 0, 1, 2, 3, 4, 5. And now if this was a plus, then all the signs would be plus. Since it's a minus, they just simply alternate. That's it. That's as simple as it is. And now the next thing we do is we just simply go through and substitute. So the A is 5dx. Now this 1 here, all right, so the 1 we don't actually have to write because it's just 1 times. The B to the 0, that's just 1, so we don't have to write that again. So we're really just concentrating on doing A to the 5th. So we're going to put it in, we're going to emphasize with parentheses here. So 5x, so we're going to substitute in with parentheses to the 5th power. And a lot of times if students forget the parentheses, they forget that the 5 is going to get the 5 exponent as well. So make sure substitute in with parentheses. So minus, we have our extra 5 coefficient now. And now A is going to be to the 4th power. And the B is just simply y. Next, we have our 10, and a is to the third power now. And b, which is just y, is to the second power. Now, the only reason why I'm not using parentheses with the b when I'm substituting y in is because it's only y. Now, you could just substitute in parentheses if you want to, but it's not going to make a difference. The reason why I'm making sure that I substitute with parentheses for the a is because you have that extra 5. If you forget about that 5 with the exponent, you're going to get it incorrect. All right, so here we go. So negative 10. The a now has an exponent of 2. And then the b to the third power, so that's going to be y to the third power. And here we go, 5. And now the a is only going to have a 1 now for an exponent. And the b is now going to have a 4. And the last one, well, again, that's 1. So this is 1 times a to the 0 is 1. That's what it's saying, 1 times 1. We don't need to write that. And then b to the 5th power, well, that's y to the 5th power. Whew. If you see what the binomial theorem looks like compared to this is actually not much. That binomial theorem to me is kind of crazy, but don't tell anyone I said that. All right, here we go. Next. Let's just simplify this. Ooh, 5 to the 5th power. What in the bleepers is that? Don't mind me when I say bleepers. I like that term. Anyways, okay, 5 to the 5th power is 3,125. All right, so 5 to the 5th power is 3,125, and then we have x to the 5th minus, okay, now here we go. A lot of times students will forget. We do have this extra guy here. So we're going to do 5 to the 4th power and then times that by 5. So 5 to the 4th power times by 5. And that's going to end up being at the same number. The only reason why is because we had 5 here, 5 to the 5th power, and then we did 5 times 4 to the 5th power. It's just coincidence for this one. So 3,125. This time it's going to be x to the 4th, and then just simply y. All right, let's keep trucking along here. So over here, the next one, we have plus 5 to the 3rd power times 10. Okay, so 5 to the 3rd power times 10. So 1250. So 1250. X to the 3rd, y to the 2nd. And next, 10 times 5 squared. Okay, so 10 times 5 squared. Oops, almost got the squared. 250. So 250 this time. X to the 2nd. Y to the 3rd. And now next. Now this time is just an exponent of 1. So that's just 5 to the 1st power. So it's just 5 times 5, which is 25. X to the 1st. Y to the 4th. And then just simply minus y to the 5th. Whew. To me, that was a lot more simple. A lot more simply done than using the binomial theorem. You can go ahead and use the binomial theorem if you want. That's no problem. It's completely up to you. But this is using Pascal's triangle. And we got our extra coefficients here from the Pascal's triangle. And we just simply counted down the first one from the exponent we had, which was 5. 8 to the 5, 4, 3, 2, 1, 0. And counted the second one up. 0, 1, 2, 3, 4, 5. And then we just expanded from there. And so now we got to input this big ugly thing. Oh boy. And this is actually kind of where a lot of mistakes happen. We get some typos when we're trying to input that. So let's just go one by one here. All right. So over here we have 3, 1, 2, 5. Oh, I already almost forgot the 2. 3, 1, 2, 5. X exponent to the 5th power minus 3, 1, 2, 5. X to the 4th, and then y, and then next plus 1250 x, and we have exponent to the 3rd, y, exponent to the 2nd, and let's scroll over. All right, and then we're going to have minus 250 x, use their exponent button, squared y to the 3rd, and then plus 25x y exponent to the 4th minus y to the 5th. Whew, there we go. We got it. Hopefully we had no typos there. But since that was a minus, we also have to make sure it should be alternating signs. So the first one's positive, negative, positive, negative, positive, negative. Good to go. Whew, that was a tough one. All right, let's keep trucking along here. Let's do a new one here. 7 jokers or jokes are listed in a magazine. And how many ways can people select their 3 favorite jokes from those listed? So this, if we have to think about it, we have in the last workshop we had permutations and combinations. Permutations is when the order mattered. Combinations when it didn't matter. So if you think about it, in how many ways can people select? How many people can select 3 of their favorite jokes? Well, the thing is, if you're taking like say joke number 1, and let's just write this out. So we have joke 1, 2, 3, 4, 5, 6, 7. And so it says they're going to select their 3 favorite jokes. Okay, well, what if I chose my 3 favorite jokes are 2, this is just an example, 3 and 5. So if I took the first one, 5, and then I was like, oh, I think 3 and then 2. Well, that's me choosing the same jokes as if I chose 2, 3, and 5. So the order doesn't matter. Whichever way I pick those 3 favorite jokes, it's going to be the same 3 favorite jokes. So this one's going to be a combination. So it's going to be 7 combination 3. Or sometimes I like to say 7, but you're choosing 3 of them. So what does this look like? Well, that looks like 7 factorial over 3 factorial, and then 7 minus 3 factorial. Ooh, well, let's say factorial. Let's take this calculator out here. And let's go through and do 7. Let's actually see what 7 factorial is. And 7 factorial is going to be 5,040. All over. Well, 3 factorial is easy. That's just 3 times 2 times 1, which is 6. But we'll show you here too, just in case. And 7 minus 3, well, that's just going to be 4 factorial. And so 4 factorial is 24. And so I'm left with 5, 0, 4. Oh, 0, 4, 0. Divide by 6 times 24. So let's get a parenthesis in there. Divide by 6 times 24. All right. And let's hit enter and see what happens here. We end up with 35. 35. So some students ask me, when I'm using this calculator, and I was taking this and I just put it right in line. So divide by 6 times 24. Will that get me the same answer? Well, the answer is no, it won't. Because what you're telling the calculator to do here is take the 5,040 times it by 6, or excuse me, divide by 6, and then you're going to take that result and times that by 24, and you get the wrong answer. And so that's the reason why I put those grouping symbols in there around that 6 and 24. But let's say also, so that's one mistake I do see these students make. To avoid that mistake, you can actually just simplify the bottom again. 144, you can do 5040 divided by 144. And there you go. Now, this calculator actually has, let's see here. So if I do 7 and I go over here, it actually has combinations. 7 combination 3, 35. So there you go. So that was a combination. Let's see here, 3, 5 ways. Next question here. All right, so you're going to get one that's a question similar to this. All right, so this one, all right, so we're in one bowl, we're going to have 3 scoops of ice cream, each a different flavor. How many bowls are possible? Okay, so very often, I'll tell you the first common mistake I see is this. Students will think, oh, okay, I have 3 options. First one is 23 options. Next one, I have 22 options. Last one, I have 21 options. Good to go. And so they think that the simple counter principle will work for this. Well, another way to think about that, the way a student would make this mistake, is a permutation. So say we had 23 and we chose, or we're looking at arranging 3 of them. Well, this would be this equal to 23 factorial over 23, or minus 3. Well, that was a bad 2 factorial. And so 23 minus 3 is 20. And so this ends up to be 23 times 22 times 21 times, oh, let's make sure we have some room here, times 20 factorial over 20 factorial. So the 20 factorials will cancel, and I'm left with 23 times 2, 22 times 21. Okay, great. But this one here wants to know how many such bowls are possible. How many such bowls are possible? So say if I have chocolate, mint chocolate chip, and vanilla. Well, if I choose those 3, if I choose vanilla, mint chocolate chip, and chocolate, it's the same bowl. And so this one actually is not a permutation problem. This one's not a counting problem. So the mistake that students make is they think it's permutation. They say, oh, okay, first option 23 times 22 times 21, but that doesn't take out any of the duplicates. This problem actually is a combination problem. So this one is actually 23 combination of 3, because we want to make sure we take out all the duplicates. And so let's do that quickly in our calculator here. We have 23, and we're going to choose. So this one we're going to choose 3. It ends up to be 1771. 1771. And you know, that's opposed. That's opposed to doing this. So there is 10,626 ways to arrange the scoops of ice cream. So say if you had like a little bowl, like a long bowl, and you're arranging the ice cream, there's that many ways to arrange it. Well, we just want to know how many different bowls that we can have, how many different, options we have. Well, it's actually 1,771. Because again, if I have chocolate, vanilla, and mint chocolate chip, doesn't matter which way I order those 3 will be the same. It'll be the same option. So this one's a combination problem. So this one's going to be 1771. So we have 1771. All right, let's keep trucking along. All right, so for this one here, we have 2 series here. So the first one says, what is the sum of S6 of the first 6 terms? So we want to find the sum of the first 6 terms of this one here. So, well, they're alternating signs. What's going on here, though? So we're at -5, we go to 20, go to -80, go to 320. So basically, in essence, we're multiplying by -4 each time. -4 each time. And so let's take a look. So that first term there is, so this is actually going to be, this information for the second part. So we have -5, -20, oops, it's +20, and then -80, times that by -4 to get +320, times that by -4, and 320 times 4, is 12, negative 1280. And then times that by negative 4. And so that's going to be positive 5,120. All right, so the first part says sum the first 6 terms. So here we go. So that's 5 negative plus 20 plus 80 negative plus 320 plus negative, or 128, oops, 80 negative plus 5120. And let's just make sure we have all those terms there. Negative 5, 20, negative 80, 320. All right, looks good. Uh-oh, that's one mistake with this calculator. I ended up having that last number twice. Let me bring this other calculator out here. I like this one better. Here, let's do this one. So we have negative 5 plus 20 plus negative 80 plus 320 plus negative 1280 plus 5120. All right, negative 5, 20, negative 80, 320, negative 1280 plus that. Okay, here we go. So 4095. So 4095. So here we go. So 4095. Next it says, what is the sum of the infinite series containing all of C of n? All right, so now C of n here, if we take a look here, this one, it's actually dividing by 5. Negative 5 divided by, well, it's actually divided by negative 5, is positive 1 divided by negative 5 divided by negative 5. So this one is going to go along this, this pattern here. If the r value is less than 1, or between negative 1 and 1, then it follows this pattern. So the sum of the series is the first term over 1 minus r. But let's just think about what I just said there. Let's actually write out what the sequences are. So the first one here, a sub n, that equals the first term, which is negative 5, and then that's going to be times, and that was negative 4 to the n minus 1 power. And this one over here, C of n, C sub n is the first term, but this one is negative 1/5 over, or not over, to the raised to the n minus 1. And the reason why I got that is this first spot here, that first spot is always the first term, and it's going to be times the common ratio. Well, the common ratio is what's actually happened to it. Well, this one here is being divided by 5. Well, multiplying by a fraction is the same as dividing. And so when this r value here is between negative 1 and 1, it follows this pattern. So the sum actually ends up to be really, really simple. So the sum, that's an S, not a 5, is that first term over 1 minus, and that's going to be negative, or 1/5. Okay. And so on the bottom here, we end up with negative 5 over 1, that ends up to be plus, of course it's a double negative, and that's going to end up being 1 plus 1/5, and so it ends up to be 6 over 5. So it ends up to be 6 over 5. And then so from there, what we can do is that can actually come up and multiply by the reciprocal. So it's going to be negative 5 times 5 over 6, which ends up to be negative 25 over 6. So that was going to be what the sum of that infinite series is going to be, negative 25 over 6. So let's put that here. So that's negative 25 over 6. And the last part says, what is the product of basically the first two? So we're going to actually multiply that guy. We're going to multiply that by 4,095. All right, let's take out our handy dandy calculator. And so now that's going to be 4095 times negative 25 over 6. And we end up with, all right, negative 1,700, oh my goodness, negative 17,062.5. All right, so negative 17,062.5. There we go. Good to go. All right, let's keep moving. Here we go. Next question here. All right, so this one here says write a formula for the general form. All right, so this is going to be general form for this sequence here. So that one there, let's think about that. So we have 4, negative 1, negative 6, negative 11, and so on. This one's a little different than the last one that we dealt with. This one looks like it's consistently being subtracted by 5. Subtract 5, subtract 5, subtract 5, and so on. So it keeps subtracting 5, so we have something called a common difference. And so a sub n here is going to equal the first term, and that's going to be plus the common difference. Well, in this case, it's going to be minus because it's 5. So minus 5 times n minus 1. Now let's see, let's make sure this actually works. So the first term is actually is going to be 1. So if that was 1 minus 1, which is 0, negative 5 times 0 is 0, so it ends up to be 4. It works. First term, or second term, excuse me, 2. 2 minus 1 is 1. Negative 5 times 1 is negative 5. 4 minus 5 is negative 1. So this actually does hold, so we're good here. But it says to do simplified form. So let's distribute that negative 5. So we get negative 5n. Negative times a negative is a positive. And we combine the 4 with the 5, and so we get a sub n equals negative 5n plus 9. All right, and so over here, it's going to be negative 5n, oops, it would be n plus 9. And so now we want to get the 20th term. So we want to get the 20th term. So a, oops, that's supposed to be a 20. A sub 2, 0. And so that's going to equal negative 5 times 20 plus 9. All right, and this one's pretty simple to do, but we'll put it in the calculator so you guys can see it. All right, and so we have negative 5, oops, negative 5 times 20 plus 9 ends up to be negative 91. All right, so over here, negative 91. All right. Let's keep going. Next question. Okay, so for this next problem here, we're dealing with committees. We have 12 males, and we're going to choose 3 of them. We have 7 females. We're going to choose 4 of them for this committee that we're choosing. So now think about what we said here. Now, this is going back to permutations, combinations. If I'm dealing with a committee, and now there's no specific positions on the committee, we're just picking people. If we're doing this, we're choosing them. And say if one committee had Sally and Mike and Rhonda, it doesn't matter what order I picked them in. If I pick Rhonda first, Mike, and then Sally, it's the same committee. So order does not matter. This is going to be a combination problem. And so we're going to do them separate here. So we have 12 males, and we're choosing 3. And this is going to be a combination. Oh, that's kind of funny, combination. It's actually going to be a combination of the combination and the counting principle. And next, we're going to have 7 women, and we're choosing 4 of them. All right, let's take our handy dandy calculator. And so we have 12. And we're going to choose 3. So that's 220. And then over on the other side, we have 7, and we're going to choose 4. And that's going to be 35. And so 220 times 35 is 7,700. All right. And so, how many ways can we pick 7 representatives to be for the committee? So 7,700. And how many ways can we pick? How many ways can we choose? 7,700. All right, we're almost done here. All right, so this one actually does say, use the fundamental counting principle to solve the following problem. In a plan for area codes, the first digit could be any number from 4 through 7. The second digit was either 0 or 1, and the third digit could be any number except 0. With this plan, how many different area codes were possible? So now this one, if we think about this one, say I have an area code of 410. Well, it's a different area code if I have 401. So in this particular case, order does matter. So this is not a combination. This is more similar to a permutation, or it's similar to a counting principle. And so we're going to use more of the counting principle here. So we have 1, 2, 3 spots for the area code. First one is the first digit could be any number from 4 through 7. So let's think about that. 4, 5, 6, and 7. It says any number from 4 through 7. So there's 4 possibilities there. The second digit was either 0 or 1. So there's only 2 possibilities there. And the third digit could be any number except 0. So that's actually 9 possibilities there. So with this plan, how many different area codes were possible? Well, let's multiply. So we have 4 times 2 times 9. And so that's 72. 72 possibilities. All right. So that there was an example final exam. So hopefully this was helpful, and you can refer back to this video, pause, play, rewind as many times as you'd like. And I just want to make sure I set you guys up for success and hope that you do as well as possible. I hit submit, so just to verify, yep, we got 100%. So on this practice test. So let me know if you need assistance. I hope everyone has a blessed week.